Baruch Hashem, you're a bad Jew.
Shalom.
Hey, welcome back to another episode of Bad Jew, the place where there is no such thing as a bad Jew. With me today, we are talking with Elie Fader and Aaron Zimmer. How are you gentlemen today?
Good, Chas. Glad to be here.
Awesome. Yeah, no, it's great to have you here. And I'm really excited to explore the scientific lens of how we view God and the way that we're going to do that. We're tying this in a little bit to your podcast as well. Everyone should seriously go check out this podcast, Physics to God, available on your favorite podcast platform. Just a quick rundown. How did you guys start this podcast?
So we were, I guess, for years, we learned Torah together. And we're also, by the way, I'm Elie. So we learned Torah together. And we also discussed, we're both very interested in math and science and physics and philosophy and psychology, all different things. And for years, we've been discussing ideas related to God and science, physics and science, God and science. And yes, we'll tell you more about the story, but basically, Aaron came upon a line of reasoning about something called the constant of nature, which he discovered, and through many of our conversations, we realized it actually leads us directly towards the existence of God. And fast forward 10 years later or whatever, and here we are talking about it and trying to present it a broad audience.
Amazing. Well, very cool. With that being said, normally we do the 4-minute Bad Jew challenge, but since there are two of you, we're going to split up your challenge into 2 minutes each. Yes, that's right. I can do math, everyone. This, just for the record, I know how to do math. So with that, I'd like to first start with Aaron Zimmer here. Aaron, I'm going to go ahead and put the timer on my shoulder. Are you ready for the Bad Jew challenge?
Okay, I'll try. Go ahead, Chaz. Go ahead.
Excellent. Your life story in 2 minutes. Echad, shtayim, shalosh, yalla.
Okay, Chaz, I'm glad to be here. I was raised as a modern Orthodox Jew. I was born in Denver and I grew up in Queen. I got a degree in physics in college. And after that, I had to decide what I wanted to do. I was choosing between graduate school or other more professions. I was fortunate to have the ability to learn how to trade commodity futures. So oil, natural gas, gasoline, cotton, sugar, coffee, those different commodities. I did that for about 11 years. I used the framework of physics. I was able to transfer that idea of how to model market quantitatively and set up models. And I've been studying Gemara also for many years through a advanced analytical method called the Brisker Method. And I used that to conceptualize certain relationships between commodities and prices. After 11 years, I was fortunate enough to be able to retire. And I've been able to work on, this podcast of writing a book with Elie. The podcast is based upon that. And basically just devoting my energy toward physics, one area, but also all other areas, psychology, history, biology, different areas, trying to synthesize different areas of knowledge and use them to understand the world and our place in it.
Excellent. Well done. And next up to bat, we got Elie Fader coming in to bring us home for the 2 minute Bad Jew challenge.
No.
Again, proving that I know math. 120 seconds, your life story. Are you ready?
Yes, I'm ready.
Excellent. Echad, shtayim, shalosh, yalla.
Okay, so we got Elie Fader. I grew up in a home which had a strong balance between Torah and worldly matters, science and other profession. So my grandfather was a rabbi and he was a chemist. My father is a rabbi and a lawyer. And they kind of brought off there was a strong emphasis on excellence in both. And as a kid, I was like that math, whatever, call whiz, call nerd, call whatever. But I was like that guy who knew how to do math. So it was natural to me to go into math. That was like my calling. So when I went to college, that became the thing. And I also, again, I had a strong background in Torah. So it became natural for me to pursue becoming a rabbi and also to pursue mathematics. So I ended up getting a PhD in mathematics. And now, currently, I teach math in a community college in New York. I also teach the Gemara share or Gemara, Flemish, Bible, whatever classes in the local yeshiva. So, yeah, this is I devote much of my time towards combination of math research and learning Torah. And then
How much time do we have left?
You have 40 seconds.
Okay, great. So now we think about Aaron and I. So again, so we're buddies, and we kind of come at this. We discussed these things very a lot, but in our discussions, we discovered in my job as a mathematician, but I'm really like a math and you probably again, it sounds like you're really good at math. We're divided by two. But most of my students are kind of like you, and they have a hard time understanding math. And my job is to kind of break down math to the people who can understand it and people who don't quite get it. So again, and Aaron's like he's involved in the advanced physics thinking and all that. So kind of we decided to make a podcast to be able to take these ideas, these are abstract, complicated, that people are afraid of, and we decided to try to present them, break them down, present it in a way that really could convince or could talk to every person and help show them that physics to God, that physics leads to God.
Excellent. Well done, gentlemen. So, based on the title of this episode, is God real, right? Okay, cool. Not a lot of people ask that question every single day, but we're going about this with a twist. As you've pointed out, you have now scientifically proved that God is real. So, how do you scientifically prove, or how do you scientifically back the concept of God being real?
Let me first, you have to qualify in a certain sense what you mean by proof in this day and age. If you say you have a proof of God, sometimes people think you mean like a mathematical proof of God, where it's going to be an absolute proof and everybody's going to have to agree. Once you have these premises, these conclusions logically follow, it has to be. So there's no such thing as that. This is not mathematics. Almost nothing in the world can be proven besides mathematics in certain trivial statements. So what we mean is a compelling rational argument which will convince a person that listening to it, who's open-minded, coming in with the possibility God exists, God doesn't exist. Compelling argument based on science that God does exist, that God is real. And, really enough that you'll base your life upon that idea, that it will influence how you view the world. And that's one of the advantages of doing it from science. A science-based argument is that the idea of God is not just something that you're told about by authority, your parents, your teachers, your society, but when you see the argument from science, from physics, where God, the proper inference, which we'll discuss, I guess, in more detail soon, you see where God fits into the picture of reality, and God becomes real to you, just like gravity is real, just like, electrons are real. Now, they're a little bit abstract, and God is abstract too, but the idea is for God to be real so that he's just not just a story that people have told you, a make-believe idea, but something that you see as real to you as you know about, other things in physics, abstract ideas that you believe to be true.
Yeah. Okay. So I just want to add another, I guess, disclaimer you could say is like, when we say that we're scientifically proving that God exists. So one might think that we're saying God is like subject to science, like we're doing an experiment and make predictions, and it's not quite science. It's not like the same way we have scientific theory. The God is a philosophical question, and the God is they're presenting a philosophical argument. But you think of philosophical arguments sometimes like pie in the sky thinking, where you just sit back in an armchair and just think about, oh, God exists because whatever. But that's not. This is like more ground. It's like science-based philosophy. Is that our argument, which we're presenting, is that an analysis of recent discoveries in modern science lead to God, point to the existence of God. And whereas scientists, physicists, and the new atheists would like you to believe that science has shown that God is kind of an old ancient idea, God is dead, like we're talking the God delusion, things like that, we show that the opposite is the case. Proper analysis of science and of these recent discoveries, again, it's something called fine-tuning, leads towards the existence and to the conclusion that God is.
Sure. Okay. So I appreciate you explaining that and I guess adding a differentiation, the fact that you can't provide the scientific theory the way that we know it, or the scientific way of discovery into God Hashem. It still is a philosophical topic. But you keep on using this expression, which one more time, did you say it's a fine tuning? Is that what you said?
That's fine tuning.
Yeah. So what is fine tuning exactly, and how does that apply to science?
Okay. So the key idea is the argument comes from studying the fundamental parts of the universe. Now, that fundamental means the most basic parts of reality. So, for example, fundamental physics is the basic laws of physics, laws of nature, like gravity, that can't be reduced to anything else, as opposed to, let's say, the laws of chemistry, which are ultimately derivatives from physics itself. So when you study fundamental physics, the universe is broken into two things: fundamental particles and fundamental laws. So the fundamental particles are the things that make up the most basic building blocks of all reality: electrons and quarks, right? Quarks make up protons, amongst other things. And the laws that relate them to each other. What governs the interactions between them. And it turns out that besides for qualities, such as, let's say, two electrons, which are like charges, so they repel each other. Besides for that law of electromagnetism, that charges repel, there's quantities that are incredibly important. And the question is, for example, how strong is the strength of the repulsion between two electrons? That's a number. It's based upon the fine structure constant, which is 1/137.039999 something, something, something. And physicists only know that through measurement. There's no way to theoretically derive that from anything simpler. That's why they're called fundamental constant. Or how heavy an electron is, the mass of an electron, how big it is compared to other things. That's also a fundamental constant. It's a quantity, it's a number that's given to us as just a part of reality, a basis of reality. And the whole argument is based upon understanding that there's these quantities that are part of nature that are incredibly important for nature to make sense of nature. That idea of quantity, called the constants of nature, because they're the same always, that leads to what Richard Feynman called the mystery of the constants. You want to explain the mystery?
Yeah. Okay. So basically, again, just to summarize, maybe simplify a little bit, is so again, at the core of the laws of nature, the basic laws of nature, you have these laws, but the laws themselves have these numbers which are just put in. Again, so like this number 137.01397, whatever, or 10 to the negative 31st power, or whatever, 9.31 times 10 to the negative 31st power. You have all these numbers, and these numbers are numbers that scientists have measured. Scientists always want to try to explain the phenomena which they observe. That's in a certain sense what science is trying to do, to understand how do we explain lightning? How do we explain thunder? How do we explain anything, everything which we see around us? So we always take whatever we see. We explain life by breaking it down to chemistry. We explain chemistry by breaking it down to physics. We're trying to get down to the most basic element. And scientists were bothered by how in the world are you going to explain these constants of nature, these numbers? How do you explain why it is, or what's the source of, what's the cause of the fact that the electromagnetic charge, the repulsion between electrons is governed by this number, this constant, 137.13910397777, whatever. It's always fixed. That's then the number. And how do you explain that? Richard Feynman called this one of the greatest damn mysteries of physics. How do you explain these numbers? There are 25 numbers like that, which are built into the basic fabric of our universe. And as scientists, they don't want to just say, well, that's just the way it is. Scientists are always trying to explain, to understand. The mystery is, how do you explain these numbers?
So there's a study within Kabbalah called gematria, which is the study of numbers. And would you say that there is a direct tie between the numbers that you just described and gematria?
Okay, good question. You're asking me like I wrote a book actually called Gematria Refigured, and about gematria, and I think there is a connection, but maybe you will. Could you ask me that question again at the end? I do think there is a connection, but in order to explain it, I think I'll have to explain what fine tuning is, and then we'll.
Okay.
But that's a great question, and in a sense, yes, there's a strong connection. But
Okay.
Question.
And for the record to the audience, if this is going over your head, don't worry. It's going over my head too. Everything here is brand new to me. This is literally making my brain explode within my cranium. So continue. Go ahead.
Okay, so let me simplify based upon that a little bit. Okay.
Yeah. I need the dumbed down version, please.
This is
Thank you.
the simple version. The simple version is physicists want to explain everything in the universe. That's the goal. We're trying to explain everything. And the question is, how do you explain a number? Is it the most fundamental thing, these 25 numbers? At the base of reality, there's just a list of 25 crazy, arbitrary, random numbers. That's the ultimate basis of all reality? Or is there some deeper explanation for the values of these numbers. That's called the mystery of the constant. How do you explain a number? How do you give a deeper explanation for it? And if you can't give any deeper explanation, then you just have to say, well, that's the way reality is. The ultimate reality, the ultimate explanation of science is that the basis of all reality is this list of quantified, ugly, random, arbitrary numbers. Physicists don't want to say that. That's lacking as an explanation for physicists. So they were searching. This was Feynman who said that statement in 1985, and it was a tremendous mystery of just how do you explain it. The next step after the mystery, it really happened in the course of the 80s and 90s. It became much more pronounced. Mostly in 1998 is when fine-tuning really just blew up and everybody started recognizing it. The key was to realize these numbers are not arbitrary random numbers, but they were arbitrary in the sense that their values could have been anything. And what would have been, who cares? What's the difference? Is 101 over 137, 100 over 39? What's the difference? It doesn't make a difference. So the electrons repel each other a little stronger, a little weaker. You would think it doesn't matter. It turns out that it does matter, that these numbers, if they were a little bit different, a few percent here, a few percent there, then you don't get atoms. If the final structure constant was a little stronger, the protons blow apart. There's no stable atom. If it's a little slow, like the electron was a little bit bigger, again, you don't have electrons, protons. Everything just collapses, become neutrons. There's no atoms. There's no molecules. There's no planets. The stars don't work. And it was really 1998, the cosmological constant, which is this number that comes from general relativity, and it determines the expansion rate of the whole universe, how quickly the whole universe expands. And if the number was an incredibly tiny number, it's a decimal point followed by about 120 zeros, and then a 1. It's so small. Think about how small that number is. The number was a little bit bigger. The universe would have expanded too quickly. Galaxies don't form. If the universe if it was smaller, then the universe collapses right in on itself. And the fine-tuning means the discovery of fine-tuning, which again, there's a scientific consensus on this. This is not our idea. Scientists basically almost all agree to this idea that if these numbers were different, then the complex universe doesn't exist. It doesn't emerge. There's no atoms, molecules, planets, stars, life, galaxies. None of this stuff doesn't work. And that's what fine-tuning means. It shows, it's a clue. It doesn't give you the ultimate idea, the solution of what the constants are, and that's Elie can discuss in a second, but it points you in a direction. It thinks, how do you explain these numbers? Well, this critical piece of information we have about the numbers is that they're not arbitrary, they're not random numbers, but they're very important and their values related to all the complex things in the universe.
So if you could explain, and can you give me an example of when someone would use fine-tuning to make a discovery of some kind?
Okay, so this was Steven Weinberg. He predicted before they measure the cosmological constant, the rate of expansion of the universe, how quickly are stars moving away from each other. So physicists for a while assumed it was 0, and that it could easily have been 0. It didn't have to be this incredibly tiny number. But Steven Weinberg predicted, he just said, listen, if this number is all bigger than this, that tiny number with 120 decimal places, if it's at all bigger, then we couldn't possibly exist. The universe would have blown apart. So if we're going to find a cosmological constant, it must be that it's within like a certain small, tiny range. Now, physicists assumed it was going to be 0 because if it's 0, you can give a qualitative argument why something is 0. Maybe you have two things that cancel each other out, certain symmetry arguments. You can give reasons why something is 0. So they figured it probably was 0, but he was able to show that if it wasn't 0, for whatever reason, it couldn't have been much bigger than that. And when they measured it in 1998, it turned out it was exactly within that tiny little range that he predicted. And it was one of the, an amazing, shocking discovery of how is this number not 0, but still within this tiny range.
Okay, just to simplify it a little bit here. So the idea of fine tuning, it's like an analogy is like, think of an idea of like dial, the idea of like on a radio or something. And you can imagine, this is an example, which is given by a lot of people, is that the universe kind of has these, so to speak, they're not actually dials, but you can think of it as there are these numbers. And every number, like again, the 130, 137, whatever, like every constant has a certain number. Now, theoretically, as far as physicists could understand, those numbers could have been any. But it turns out that if the dials weren't set to exactly or to very, very precise numbers within a very small range, you'd have the laws of physics, but our universe would be total chaos. Just have a bunch of elementary particles electrons banging around, and quarks banging around. You wouldn't have anything amazing in our universe. You wouldn't have atoms, you wouldn't have molecules, you wouldn't have planets, you wouldn't have stars, you wouldn't have life, you wouldn't have anything. So the idea of the discovery of the numbers are exactly the numbers, the values that they need to be in order to result, when you fast forward our universe future from the beginning, that will result in this amazing world.
So what you're saying is that fine tuning is like this perfect, precise recipe for creating the universe.
Right.
And any missing ingredient or any changed portion of the recipe would just create to utter nothingness.
Right. Well, the not utter nothingness, just like meaningless, chaotic, uninteresting, no complex entities.
Fascinating. Okay. Still abstract to me, but this
it is
becoming
abstract.
clear.
Yeah. It's still physics. They're not getting around that. What is the interpretation of fine tuning? So what does that mean? What does that show you? Okay. Now, before we get to what we think is a straightforward interpretation, and you kind of know we're going to go to God, but I want to just show you how this is not like a small problem that we're making up, the fine tuning, the mystery of the constant. This is something that scientists talk about as a major problem, the mystery, and fine tuning demands some sort of paradigm shift. And in fact, scientists, the preferred solution amongst atheistic scientists is called the multiverse. Okay, we're not going to get into that too much. We don't have that much time here. Just to give, I just want you to know, I don't want to just present our side. I want to just first present what scientists say. Is they say that the way they make sense, how do you explain how these numbers got exactly the right way to allow for this amazing universe to exist, is that there's an infinite number of parallel universes. In all these other universes, the constants are different numbers. So instead of one over 137, one's 100, 150, 190, 1 million. It can be anything. So all the different possible values do exist in this infinite number of other universes that really do exist in their minds of top physicists, the top most brilliant people in the world believe in alternate universes. And they say, listen, if that's true, most universes don't have any molecules, don't have any planets, don't have any life. And since there's no life, there's no people in those universes who can ask the question, why are the laws of nature the way they are? So it's only in that small percentage of universes which actually have seemingly fine-tuned constants that people even exist, that life, intelligent life exists, ask that question. And there's an observer bias. You think, why are the laws fine-tuned in such a perfect way? How do these numbers get that way? Well, saying it's not true. It's an illusion. Really, they didn't get that way. There's every possible combination of constants really exists. And it just happens to be that you're the one that allows for intelligent life to exist. Okay, so we think that's not a good scientific theory. We think it's a bad philosophical theory. It's not testable. It doesn't work by the regular methodology of science. But again, it's not the show to start criticizing how you break down the multiverse. We're going to do that in season 2 of our podcast later this year. But first, we want to just take the natural step to develop. How does fine-tuning lead to God as opposed to a multiverse? The point of the multiverse just is to see that if scientists are saying something as wild and speculative as an infinite number of alternative universes, there must be a real significant problem here that demands a paradigm shift in how scientists view the world.
So I know for a fact that when it comes to Jewish death, that the way, I should specifically say, death through the lens of the Jewish perspective, we oftentimes talk about entering the next world. Is that the equivalent of a multiverse then?
For scientists?
Listen, not for scientists. Maybe that's like how that, who knows?
I just give this in the multiverse. There is, we saw scientists talk about this, so we should bookmark that.
Yeah.
They're talking about there is a multiverse, infinite number of parallel universes where everything happens. So there is a multiverse where after you die, your atoms, years later randomly assemble and there's a resurrection of the dead, and that happens. And scientists, they'll talk about that, like that's real. And I said, this is getting scary. You know what I mean? Like, because in a multiverse, there's an infinite that happens in one of the universes. In fact, it happens an infinite number of times. That's part of the problem scientists have. Once you have infinity is a really big number. And if you have an infinite number of universes, everything possible happens. And it's possible for your atoms to randomly rearrange to have a resurrection of everybody at the same time. So in a certain sense, if you mean by the afterlife or resurrection of the dead or something like that, yeah, there is a multiverse where that happens. Now, scientists can say, how likely is that? Whatever. It happens an infinite number of times. So that's part of the absurdities you get involved in if you actually believe in a multiverse. And part of the challenge scientists have of working out a sensible explanation of our world if you want to actually believe in infinite numbers of parallel universe.
The main thing here is like, there's no evidence at all that there's more than one universe. Everything which we see, with all the telescopes and everything you've ever seen in any pictures, any experiments, anything is always the universe. The massive, everything you've ever learned about is the universe. There's no evidence that there's anything more than the universe. All we really observe is one universe where these numbers are fixed, are fine-tuned at a specific value, which will result in our unbelievable, amazing, structured, beautiful universe coming about. And what we're arguing in physics to God is that the fact that those numbers are set to exactly the numbers which they need to be in order to result in our amazing universe indicates an intelligent God. Saying is the fact that the numbers could have been anything, but they were specifically the right numbers, which looking forward, fast forwarding it throughout the history of the universe, will emerge, result in our amazing universe, points to the fact that they're the result of a God or of a cause who's intelligent, who acts intelligently, who knows what he's doing, who's trying to bring about the universe which we see. Because otherwise, how are you going to explain the fact that the numbers are exactly these numbers? There's no way to explain it other than positing that there's infinitely many universes out there, which we could never interact with, we can never see, we can never, have any way to really know about them. So, point is, scientists will tell you, oh, you believe in God, you think God is real? Well, it turns out if God isn't real, the only other explanation is that there's infinitely many universes out there. So, in a certain sense, you should. We're saying evidence points directly to an intelligent cause, and the only other way out of it is if you want to go with this scientist who say, you know what? There's no God. There isn't one God who created our one amazing universe, but there's no God, and there's infinitely many chaotic universes out there. Ours happens to be the one which coincidentally looks like it has order, but it's really just a thing.
Let me just qualify one thing. You're saying it's God or the multiverse. There really are two other logical possibilities. Either the constants just absolutely exist, like fundamental existences, or there's some qualitative law that generates them. We picked it up on our podcast. This is, again, a shorter version to, listen to it's really the first 5 episodes on Physics to God for a much more detailed explanation, which does take up other possibilities and shows why they don't work. But yeah, I just wanted to qualify that. Just to there are logically other possibilities that end up not working out. Even scientists don't really hold by in general. But it comes down to, once you have fine tuning and there's what seems to be a purpose to the laws, that's the shocking thing, that in a sense, the numbers have a purpose of they're these values in order to produce atoms and molecules and planets and stars and life. That's something strange. And for a scientist, that there's a purpose. And either you take that purpose seriously and say, therefore, cause of the laws of nature is intelligent because it operates with a purpose. It's able to select out one value from amongst the infinite number of possible values for the purpose of producing its objective. Or you say that it's just all one big illusion. There's an infinite number of universes.
So just to close out here, the question.
Let him ask the question, Chaz. You got to ask the question. Okay, go ahead, Chaz. What's the?
No, I'm a little bit. It's kind of like drinking science out of a water hose right now. I got to be honest with you. It's a lot. Do my best here. By far one of the most challenging episodes to facilitate on this show so far. I gotta say, this is not my area of expertise, but what the one thing I was going to bring up that you kind of brought up, which is great, which is like in the practical situation, right? Where I happen to have that one friend who is an atheist, right? And that atheist friend says, no such thing as God, right? My question was going to be, how do you prove it? But the answer right now is fine-tuning. Talk about and discuss the background of fine-tuning, why it comes up, how frequently it comes up. So, okay, understood. There's something in physics called fine-tuning. It's numbers that are repeated, the perfect recipe that creates the universe. And there's no further explanation beyond the fact that we keep numbers. And because of that, there has to be meaning behind all of this that we see. Yes. What dots am I missing that I should be connecting here?
You're pretty good.
Pretty good job.
Okay, cool.
Yeah. What? It's just interesting. Again, we're talking. This is a half hour. We thought we had only 3 minutes to talk about the whole argument, but it's, again, on our podcast, we break this down. We have 10 episodes where we go through much more slowly, much more carefully. We give analogies, we break it down. So again, our attempt here is to show that if you're an atheist, or if somebody is an atheist, or somebody just kind of is seeking out meaning in their life, and they just have this part of them that feels like, is God real? Is this a real thing? It does feel like this made up thing. You should know that there is a place to go. There is a place to look. There is signs those point in that direction. If anyone wants to pursue it further, you can check out Physics to God. We really spell it out in a lot of detail. And we're willing, if anyone has any questions, you could email us, physicstogod@gmail.com. And again, we're happy to be able to, we know a lot of people, there are people who just can't embrace Torah or religiosity if in the back of their mind, they just feel like this is make-believe. And that's what we're trying to provide the service to people, is to show people that there is a path that science actually leads and points to the existence of God. So yes, it is complex, and some people may not follow all the details of it, but it is a value to knowing there is, if you want to look into it, and we really think it holds up to close scrutiny.
Elie and Aaron, this is amazing. I really appreciate it. I want to thank you also for having grace for my learning curve as well. It's super exciting. Here's what I'll say. So this is super exciting, super fascinating stuff that every person should be able to take with them. And I've spoken with many of my followers who have loved the idea of connecting science with religion. And this is just one of the many steps, one of the many episodes that we'll do to accomplish that task. I want to encourage everyone to go check out Physics to God. It's a really great podcast. Listen to the first 3 episodes. If you can imagine what the first 3 episodes are like, it's a lot of this kind of discussion as well as further. And Elie and Aaron do a really great job at explaining it for a simpleton like myself. So I want to thank you guys for, bringing in this subject in such a unique way, in such an insightful way. It's really an awesome conversation. So Elie, Aaron, kol hakavod to you guys, and may our studies continue to make scientific groundbreaking work for Hashem and for people.
Very good, Jazz. We appreciate it.
It's been a pleasure. It's been a pleasure, Chaz.
Of course. And to the listeners, I want to thank you all for tuning into Bad Jew. Bad Jew is the place where there's no such thing as a bad Jew. We have a Bad Jew WhatsApp community. If you're interested in the WhatsApp community, we have an online chat forum where you're able to, in a safe space, have conversations around the Jewish world, get dates before anyone else does, about the latest episodes of the podcast. And as well, if you go to badjew.co, that is badjew.co, C-O, you can buy our merchandise. Also, I want to announce something really exciting. We recently got a badge, a creator badge, for being the top 50 podcast within Judaica in the Jewish genre. So I want to thank all the listeners for your reviews, your comments, your likes, your recommendations, your emails to me. Your engagement has made this show what I've always truly dreamt it to be. And I want to thank you for continuing to make that dream a reality. Thank you to everyone who tuned in, and we will see you next Wednesday on another episode of Bad Jew.
Shalom.